I'm going to confess this is a little bit surreal for me. Even without COVID, I wasn't getting out a whole lot. So in 2019, I don't believe that I did any in-person live conference events like this. So it's been probably at least 3 years. I'm a little nervous. So I hope this all works for all of us. But it is so good to see you all in person, and I'm so grateful to be here and to see you. So let's talk about feedback. Where to start? Well, better just get started. This is a talk in 4 parts. First, we're going to talk about the nature of feedback in sort of an abstract way. We'll go through that fairly quickly. Then we're going to talk about software and how it applies to software. Then I'm going to tell some cautionary tales, and then I'm going to bring it home. So talk in 4 parts. Let's start with just what is feedback. It is the simplest thing in the world. You do a thing, you see what happens. You get empirical evidence that tells you if the thing that you did had the effect that you intended. And the empirical evidence part is the super important part of that, because opinions are not actually feedback if they are not giving you concrete information about the effect of the thing that you did. Now, we have a lot of very fancy ways of talking about feedback loops. There's the Deming cycle: plan, do, check, act. It's just a feedback cycle. We plan what we're going to do, then we do it, then we check to see how it went, and then we act on the information that we got. Because if you get a lot of feedback and then you do not act on it, well, that's a problem. There's the OODA loop. John Boyd gave us the OODA loop of observe, orient yourself, check, act. That's another feedback cycle. There's lean startup: build, measure, learn. Build, measure, learn. And of course, the idea here is build the smallest amount possible so that you can test your hypothesis. It's basically the scientific method. We're forming a hypothesis about what the market wants or what would be successful for the outcomes that we're attempting to achieve. And then we're going to design that experiment, the cheapest experiment we possibly can. And then we're going to observe what happened when we ran that experiment. And then that's going to lead us to form our next hypothesis. So it's just all feedback. So far, so good? Sweet, let's talk about software. This is where things get a little bit complicated. Once upon a time when I gave variations of this talk, by the way, I've given this talk a lot of times. It's slightly different every time. This time, for reasons I still don't understand myself, I decided to rebuild all of the slides. So you're looking at an entirely new deck, even if it looks a little bit familiar. I will also say this is the first time I'm giving this talk presenting from Google Slides. This is not a Google ad, but I will say that the world has gotten sufficiently different that I no longer feel the need to have everything local on my computer. The internet is actually ubiquitous. Plus also the whole download work offline mode actually works. Anywho, so let's talk about every software project ever. Whether you work in an agile way and you're shipping frequently, or you work on big honkin' things that ship every 5 years, still, yes, some of you are laughing. Hi, I'm an old. That was the way things worked. Been in the industry, wrote my first line of code in 1980. So every software project ever, at the start, you're analyzing some stuff. Now that might be an analysis phase, or that might simply be doing a little bit of user research to understand what we want to build, the problem. Really, this is about analyzing the problem that we want to solve. This is the stage at which we're forming some hypotheses. And then we're doing some design, and that might be designing a UI, it might be capital A architecture, but we're doing some design and we're implementing. Now, notice there's this curve that I haven't talked about yet. That's the speculation curve, because at each stage, we're speculating. We are building assumptions on top of assumptions. We're speculating that we understood the problem to be solved, that when the business analysts went to gather requirements from the corporate stakeholders, that they actually understood the corporate stakeholders, that the corporate stakeholders were actually saying what their needs were, as opposed to offering solutions packaged as needs that weren't going to solve the problem that they actually had. That never happens. So we're speculating at each stage. We're speculating that our design will in fact solve the problem that we identified. We're speculating that our implementation is going to work. So at each step, we're building assumptions. And then we end up iterating. Whether you were doing waterfall or agile, you still end up iterating. You'll notice the slope of that curve is starting to come down because now we do get some empirical evidence. Then we do whatever is final testing. If you worked in a very traditional kind of way, you might have an entire QA department doing the final test cycle. If you work in a very agile way, you might be putting things onto the staging server. Whatever it is, you're doing some form of final testing, and then there's a release, and that's really when the chickens come home to roost and you find out. So this is the entire life cycle of what's happening inside that feedback cycle, from do a thing to see what happens. And that area under the curve, that's all risk. So clearly, the longer this cycle goes, the more risk we're incurring. By the way, this talk has a bunch of digressions. Here is one of them. Let's talk about Schrodinger's cat. Why on earth am I talking about Schrodinger's cat? Well, first, you may have heard of Schrodinger's cat. Let me do a quick, very quick summary. This is a thought experiment that was proposed by Schrodinger, I believe in a letter in 1935 to Einstein. I might have the details a little bit wrong. But there was the Copenhagen school of thought in quantum mechanics that said that, well, it's all probability waves, and so there is the potential to have superimposed probability waves in which two states coexist at the same time, and until there's an observation that is made, those probability waves do not collapse. And Schrodinger was trying to say, let's bring determinism back to physics. Let's take a completely absurd thought experiment that starts with one cat. We have a box. It is a sealed chamber. Said sealed chamber has some poison gas or cyanide gas. That cyanide gas will be released based on the completely random decomposing of a radioactive isotope that it has a half-life of time t. So at the end of time t, there's a 50-50 shot that said radioactive isotope has decayed. If it has decayed, the cat is dead because the hammer hit the flask and the flask has released the poison gas. But if it has not decayed, again, 50-50 shot, the cat's a little alarmed, 50-50 shot that the cat could be alive if it did not decay. So this was a thought experiment, and what he was trying to say is this is clearly absurd. I'm not a physicist, but it's my understanding that, yeah, basically the probability waves collapse at the moment of observation, and the cat is either alive or dead at that point, but until then, probability waves still exist. Why would I be telling you a story about physics? So let's talk about Schrodinger's release. Until the moment that we release, we do not know if it's alive or dead. We don't have the empirical evidence. We haven't made the observation, and the release exists in two states simultaneously, which you may have enjoyed that possibility when you go into a status meeting and there's wild optimism on one side and tremendous pessimism on another. That is an example of these probability waves being superimposed, and until we actually get empirical evidence, we don't know. So until you observe in the wild, you're speculating. Now, in theory, Agile solves all this for us. Agile made the world perfect, right? 20 years old. Yeah, thank you, Penelope. For those of you in the back, in case you couldn't hear, uproarious laughter. So let's talk about Agile. There's a lot we could talk about Agile, and I'm not going to. I just want to focus on one aspect of it. In theory, you're shipping very frequently. And in fact, in my experience, that when we do all of the disciplines of Agile and do them well, we're able to ship with confidence much more frequently. And in those circumstances, what happens to that risk curve? It gets so much smaller. So we get empirical evidence, and then we can steer. When we discover that we made invalid assumptions, we can steer towards value. We can steer away from risk. So iteration after iteration, shipping after shipping, we're able to control the risk. That is the theory of Agile. However, let's talk about the reality. Even if you work on software as a service where you have the ability to deliver multiple times a week and it goes in front of real users, there still can be a difference, a thing that we are not yet getting empirical evidence about because you're putting it behind, say, a feature flag, right? So even if you're actually delivering multiple times a week, not everybody works on software as a service. I've shipped enterprise products where we could have a notion of releasable, but we could not actually release as frequently as we could create a releasable artifact. And in those cases, you definitely have these longer periods where you're not getting the empirical evidence. And particularly in those environments, here's a thing that I've seen happen over and over and over again. Here's a theoretical line. This is how much we would like to test. That's all of the system tests, the unit tests, the performance tests, everything that we need to gather information about, because a test is a thing that gets you information about the behavior of the thing that you're producing. We theoretically want to do all of this. And unfortunately, we don't quite get there. And sometimes it's a very conscious decision. Sometimes it's a conscious decision that says it is so expensive for us to do our performance tests. It requires such a large environment that is realistic, and there is contention for that environment across multiple different projects in the same organization. Therefore, we're going to schedule that for the end. Sometimes it's a less good reason for scheduling it for the end, like the performance testing is a pain in the butt and I don't want to do it, so we'll just wait until later. Hence the whole XP mantra of if it hurts, do more of it. But in any case, there is a gap between what we actually, the information we actually get, the feedback we actually get, and the ideal state. And then what happens? Iteration after iteration, we're delivering, and there's that gap. And what does that look like? Well, that gap is speculation. We're speculating that it'll be fine. There wasn't going to be that much information to discover in that gap. Penelope, I told you I wasn't going to make it better, right? Okay. So the speculation buildup happens until we get to the final ta-da when we actually release stuff. And guess what? The area under that curve is risk, which is why it is much easier to do fragile than agile. Okay, so, and yet, if you wait for that in the wild feedback, so I've been making this whole case that the in the wild feedback is the only valid empirical evidence that tells you whether or not what you released is any good. But if you wait for that, oh, you've waited way too long. It's way too risky. There is a very high probability. There's a wonderful, wonderful talk in here yesterday on the 737 MAX story. You end up with a 737 MAX class disaster if you wait in the wild feedback. So part of what I'm hoping that you will be thinking about is the different levels and types of feedback that you could be getting. A unit test answers a very specific type of question. As a programmer, did the code that I write do what I intended it to do? And if you have a comprehensive suite of unit tests without violating the expectations that any of the other code already had in the system, that tells you nothing at all, and I mean literally nothing, about the overall behavior of the system from the user's perspective. Long time ago, one of my consulting clients, I used to consult, one of my consulting clients brought me in for a project that was 3 years into a 3-year schedule, and they had not yet made it to formal QA, and they felt that they needed help with testing and quality, and at the time that was what I was most often brought in to do. And they said, well, but we've got all these COM objects. This was way back in the days when that was a thing. That was the old microservices. Okay, so we've got all of these COM objects and we've tested them all, so we should be fine, right? Oh, yeah, that project, by the way, I was only involved for a short period of time, but I later heard it was 5 years. The 3-year schedule ended up being 5 years because of late-breaking surprises. So there's all these different types of feedback. The CI system is giving you information about it running, presumably, in the different environments or configurations that it needs to run in. You probably don't run every permutation of that locally, so you probably have a CI pipeline. There is probably somebody who is doing what I'm calling acceptance testing here, and what I mean by that is somebody who is accepting that the work represents the value that it was intended to represent. So I don't mean acceptance tests like cucumber tests. I mean like there is a, say, product manager who asked for a thing and they're saying, yes, I got what I asked for. So that's a different type of feedback. Stakeholder feedback, are we going in the right direction? User feedback is the ultimate, did we deliver the value that we intended to? And for each of these different levels of feedback, there is a different cycle time, a different natural cycle time. Your unit tests, seconds to minutes. Technically, if you're running in minutes, they probably aren't unit tests, but shh, that's, seconds to minutes is not that bad. Integration systems, yeah, somebody groaned, I'm with you. But let's recognize the amount of legacy software out there and give people a pass, okay? Integration systems, CI tests, minutes to hours probably. Those acceptance tests, it probably takes hours to potentially even days before that person who is accepting the work, whether they're a product manager or they are a QA person, before they actually take a look at the thing. Stakeholder feedback can take days to weeks, and the user feedback, that can potentially take years even if you're releasing very frequently, because if you work on enterprise software, it could take years before your customer deigns to upgrade. It's a reality of life in that context. All right, so let's talk about some cautionary tales. But wait, first a digression. That is a fruit fly. Anybody know why I've got a fruit fly on my slide? Short generational lifespan. They are awesome for science experiments because the generational, the lifespan of a fruit fly is like 50 days or something, but you get new generations every 10 to 12 days, give or take. So you can do longitudinal studies with multiple generations in the span of weeks to months. Sweet! Hold that thought. Let's talk about code reviews. So this is a cautionary tale of a team that I was involved with. At the time that I got involved with this team, this project, this was their process. It was fairly traditional. It's one that you see in a lot of places. It was a pull request based process. A lone developer, developer, writes a whole bunch of code. This was in an environment where individuals were incentivized to push their features through. That's how you got a promotion. Individual ownership of things. So the lone developer would do all of the brilliant work, and then when they felt that they were ready to have their thing reviewed, it was at that point a whole thing, they would run the tests locally. That took about an hour because it was all of the tests and the tests were really slow. And then they would check in on a branch, and this was a Gerrit-based flow. I am not here to bash Gerrit. It is a tool. If you are in an environment where you need something that automates the workflow of pull requests, code reviews, I actually know nothing about how it is now. This was years ago. It is a tool, but I will also tell you, this is a preview of what's coming. I took tremendous pleasure in ripping Gerrit out of this process. In any case, you check in on a branch. CI would then run a set of unit tests taking about 10 minutes, and then your pull request is now sitting in a queue, waiting for somebody to approve it. And in this particular organization, there was a hierarchy. There were people who were so junior, they only had the ability to comment on PRs. There were people who had earned a +1. They could give you a point, and you needed to get 2 points, so you could get 2 of them, or you could get 1 of the very few people in the organization who had been ordained with a +2. Now, as you might imagine in an environment like this, who you knew was kind of the whole thing. So if you were one of those +2ers and you needed your code reviewed, you just kind of nudged your buddy and they would do the code review and your code would get in. And if you were low on the totem pole, so to speak, I'm really sorry I used that phrase. In any case, if you were of lower status, your PR could wait for a very long time, especially if it wasn't considered critical, which is why one of the saddest stories that I took away from that particular experience was a junior developer who expressed to me her tremendous frustration because she had a very small, like, couple lines of code change that she couldn't get in for an entire week. And during that week, there were other commits that were getting merged. And so she was constantly rebase, rerun all the tests, resubmit the PR for an entire week for a few lines worth of change. She didn't get anything else done that week. How incredibly demotivating. Worse, that meant that she had fewer opportunities to get code merged because through no fault of her own, she's waiting for somebody to get around to deign to review her PR. Okay, so then it would merge to main, CI runs the full set of tests. This was the entire set of things that had to happen to get a change all the way through. And that process could take a day if you were one of those +2ers who got to kind of jump the queue. But it could take potentially weeks. And in fact, at the point where we turned off Garrett, there were still PRs that were sitting there that were essentially abandoned. They were stale. Nobody was going to go through and update them. Whatever changes they represented either got lost in the sands of time or got subsumed, had been made in some other change that did get pulled in. So we made a change. We made a process change. Now I will note that the only reason this process change was possible was that we had support all the way from the top. This was not a universally popular change. There was support at a grassroots level for this change. There were people who were so happy and grateful that they were going to be able to move faster, but not everybody felt that way, and I feel I need to be honest about the fact that this was not universally popular. I still, in hindsight, this all was happening many years ago, and in hindsight, knowing how the rest of the story then evolved, this was the right decision because we were able to go so much faster after that. We were able to introduce so much more innovation. The process went to, okay, we don't do PRs, we pair on code. That's how you get another set of eyes. We all agree that it's a good and healthy thing for this project to have multiple sets of eyes on things. Furthermore, what's not represented here is we practice collective code ownership. A team owns the code base. There is no my feature, your feature. And consequently, since we're pairing and we're rotating pairs frequently, everybody ends up touching that code. So you're getting more than 2 sets of eyes on any given thing over a long period of time, but 2 is enough to get it merged into the code base. For local tests, we only run the fast tests. And yeah, they took 10 minutes. So yeah, they technically weren't unit tests. But that was so much better than sitting there for an hour waiting for your tests to be done. So the fast tests we run locally, then we check in, we lived on main, we merged to main, and then CI would run the full set of tests. And yeah, sometimes stuff broke, and then we would fix it. But because we were working in tiny, tiny increments, fixing was pretty quick too. And so now we could get changes in minutes to hours before they got merged in. So when you think about your process and the latency that it introduces, the wait states that it introduces, remember the fruit flies. We want to be able to get so many more cycles. That's what this kind of process change can give you. Okay, now let's talk about branching strategies, batch sizes, and latency. My personal preference is to live on main. I recognize that's not possible for everyone, but if you are able to do this in your context, It means that, yeah, if you're using Git, that local copy that I have is essentially a branch, but I'm making a few changes, get to green, make it clean, and then check it in. Everybody else is doing that as well. And so at any given moment in time, the amount of inventory, work in progress, that's sitting out unchecked in is a fairly small amount. So we don't get a whole lot of churn. We certainly don't have the experience that that poor junior developer, who incidentally wasn't actually that junior, that was just the status that they had been given. But that poor junior developer had of waiting an entire week to get something merged because of the amount of churn that was happening. Anyway, moving on. Feature branching, also very common. I am not here to argue with you about whether you should live on main or should do feature branching. There are trade-offs, there are good reasons to do both. It does introduce the challenge that now you've got larger batch sizes, and so you can merge less frequently. And so if you notice that although this looks like a nice, neat little diagram and it feels all warm and fuzzy, that it's not quite that simple. And the way that that shows up in this diagram is if we flip back and forth between the two, we can see that we're getting fewer merges to main. So that means that the generation cycle, that life cycle is that much longer. And that introduces, what do we know about that? Area under the curve, risk, more risk. So far, so good? Okay, that was all the background to the cautionary tale. Let's talk about a process that I do not recommend anybody, anywhere, ever do under any circumstances. But in this organization, and I have to confess, I did not see it at the moment that it was happening. My involvement happened some number of months later. I came in and I was still hearing the echoes of the screams of pain from this particular situation with a long-running team branch. It started off simply enough. We have a main, and the organization had decided, for reasons that I am sure made sense at the time, that every one of the teams would have their own team branch. I understand that in hindsight, this does not seem like a good idea. I'm hearing some of you laugh, but I am willing to believe that they were doing the best they knew how, given everything that they knew at the time. It still didn't turn out so well, but I'm getting ahead of myself. Let me go through the rest of the story. So, and now the team is treating the team branch kind of like you would treat main in a feature branch scenario. Developer A, developer B, developer C, they're all working on stuff. Developer A is working on their feature. They now merge back to the team branch, develop, and then start another feature. And then, of course, in the meantime, main is changing, and they did have a plan for rebasing off of main onto the team branch. But it was way too easy for a developer to just ignore everything that was, I'm really sorry, you're clearly having a reaction to this. It was, I am so sorry. Developer C tries to merge back, discovers that, of course, they have ignored the fact that the world was changing around them. And so they now have to... Okay, in the meantime, developer B has been cranking away on their feature. And the world has been moving on. This is, in fact, what happened. The really sad part is an entire team threw away 6 months of work. Can you imagine? Oh, I'm really sorry. I better move on. Some of you are having very strong reactions. Let's talk about test pollution. Oh, it's not getting better, is it? I warned you. Did I not warn you up front? By the way, RSpec is lovely. Thank you so much. The state of JavaScript testing is a different problem, which incidentally, just as an aside, my new thing is, it's not stealth, it's just I'm not quite sure what it's gonna grow up to be. It's Curious Duck Digital Laboratory. I am building a simulation game thing. It is, the back end is a pure Ruby gem, yay gems, and massive shout out to Davis Frank, who convinced me to make it a gem. And that has had massive payoff. But the front end is a Rails front end with stimulus for JavaScript, and so I spent like 6 weeks getting my mise en place en place for JavaScript testing. So incidentally, if anybody wants to talk about that stuff, I'm happy to show you what I've done, get your feedback. That is actually not the point of the test pollution, although there is a reason why I am mentioning this, because we'll talk about it with pollution. First, let me explain what I mean by that. Now, your feedback cycles, the information you get back can be polluted in a variety of ways. What does pollution mean? It just means that we don't trust the information that we're getting back. If you mix opinion in with empirical evidence, you now have a polluted stream. That's one example of pollution. Another big source of pollution, let's see if this feels familiar to y'all. You're a new person on a project, you start doing some work, you run the tests, or the tests are running in CI, whatever, and you see failures. And you go, wait, those failures do not appear to have anything to do whatsoever with the stuff that I changed. What happened? And your new buddy, the person who's helping to onboard you, says, don't worry. That's fine, they do that. Just kick it again. And you kick it again. I hope I still have friends after this talk, because I'm watching some of y'all's faces and I'm really worried. Okay, so you kick it again, and sure enough, it's a different set of tests that are failing. And you kick it again, and you kick it again. Okay, y'all have seen this? So, one group that I got involved with was working with a legacy system that was massively distributed and had a whole lot of threading and parallelization and very difficult to find race conditions. And they had a very long history, so long that there had historically been a very talented and skilled QA group that has built an incredibly sophisticated test harness, but because the test harness had a tendency to expose things that were both real and also not something that would be real, the developer team that did not feel any sense of ownership whatsoever over those tests or that test harness had a tendency to just discount those results until somebody went through and painstakingly did the analysis to discover whether or not that was real information. And in this environment, we attempted to reduce our cycle time, which meant developers had to own the tests, but developers had no intention of owning that set of tests. But that set of tests was the only set of tests that was giving us real information about the system. So as we reduced our cycle time, we ended up increasing risk. And at that point, I was responsible for the group. I've held all sorts of roles, and in this case, I was a VP of R&D. And I did a really terrifying thing. I pulled the big red cord. I said, we're not shipping any more features until we clean this up. And I had expected that it would take a few weeks of a concerted effort with everybody, all hands on deck, everybody cleaning this up. I was wrong. It took months. And I held my ground. And I'll just note that even in the level of authority that I had within that organization, it was a scary thing. It takes an enormous amount of intestinal fortitude to say, no, we're not going to write new features until we can trust that our tests are giving us information that we can believe. It was not a popular decision with sales. What a shock. The product managers, who incidentally reported to me, they were not happy with me. The developers who reported to me were not happy with me. Some of them were, but some of them were just of the opinion that this was unfair, that they had to clean up this mess that they hadn't made, and that they would much rather be developing new features. And so this was not a popular decision, and yet our customers and a support organization needed me to make that decision, because we were shipping objectively worse software with every increment that we delivered. So this is a very difficult situation. That is the cautionary tale, by the way. If you don't clean it up while it's a small mess, if you wait until it's a Superfund site, you're gonna end up in a situation where you have to make the excruciating decision between stop the line and don't do anything but clean up the Superfund site, or be at a very serious risk of shipping a product that frankly doesn't meet the value proposition that it's supposed to. Okay. So then, and I noticed that I'm running a little short on time, so I will tell the abbreviated version of this cautionary tale. What happens when you have both pollution and you have delayed feedback cycles? And that was this project. I was again a VP, and I had a peer who was another VP who came to me and said, "What are you doing?" "What do you mean?" "Well, your group theoretically ships software and has been unable to ship software, so your group isn't doing what your group is supposed to do. What are you doing?" Now, I knew we had challenges, but let's just say that that was a galvanizing conversation in which I decided it was time for me to understand in depth. So I started asking, and we ended up, I interviewed a whole lot of the individual contributors who were on that project. We would stand in my office and I would ask them, help me understand again, from the moment that a developer has something ready that theoretically is ready to ship to the moment that we actually ship it, what do we do again? Tell me again. No, tell me like I'm 5. And we mapped out collectively through the series of conversations, some of which happened one-on-one and some of which happened in groups. We ended up with a diagram on my whiteboard that lived there for months that showed the pipeline. And it showed the following information about the pipeline. So the first stage was there was a build step. This was shipping enterprise software. First stage is there's a build step, and then some set of fast tests run, and then if that's green, it goes on to the system tests that were in a fan out across multiple configurations and environments, as you do. And then there was a final packaging step of some kind. So basically 4 stages. And okay, well, how long does each stage take? That first build step, a few minutes. Some of you are laughing in anticipation. That first step takes a few minutes. The second step takes a few minutes. That third step, that could take anywhere from 4 hours to over 24 hours. That's a lot of variation. Why? What is different between the 4-hour runs and the 24-hour runs? Well, it turns out what I learned, and it took a long time because nobody had ever really looked at this in this particular framing in this way until we all got together, because everybody had one piece of the puzzle and we were assembling a jigsaw. But the spoiler is the reason ultimately that the things sometimes took a lot longer was because we were waiting for a lock on an environment in a pool of very restricted environments. And there was a fair amount of, at the peak of activity right before a theoretical release, there would be a lot of contention vying for one of those coveted locks on those environments. So there could be a very long wait state. So that is the delayed feedback piece, right? That thing was causing a wait state that could be variable length, but end up being very, very long. Okay, so the next question I had to ask was, well, how often are things failing? And let's talk about pollution. Why are they failing? When tests fail, have we learned anything new, or were they failing for spurious reasons? And well, the build never failed. We always got something out. Whether or not it worked was a different question, but the build never failed. The fast tests almost never failed. The failures were mostly occurring in the system tests. And they were flakes. We had a burgeoning Superfund site. So the solution to this, incidentally, we had gotten to the point where we were just wedged. We, kind of like a car spinning in sand, we were struggling to ship. And so the solution ended up being to focus on doing 2 things. One was to reduce the amount of time that the tests took and to reduce the wait states by trying to increase the number of those very coveted environments that were available. But also reducing the contention by reducing, because it turns out that when the tests fail, that thing ends up going through that whole cycle again, so that increases the amount of contention for those locks. So we needed to reduce the flakiness in the test suite until the point where when it failed, it was telling us something real. So if you are facing a potential Superfund site, here are some strategies that you can try. One is to just separate the streams. You've got blocking and non-blocking. Caveat, this only works if you trust that you have sufficient coverage in the blocking tests to tell you whether or not, to tell you about the risk in the software. That was not the case in the story that I told of the massively parallel. We didn't have enough test coverage. We did not know what we were shipping. We were definitely shipping Schrodinger's releases all over the place. If part of the reason why flakiness is persisting is that sense of tragedy of the commons, that nobody feels a sense of responsibility or ownership, or maybe even agency to clean it up, getting cross-team partnerships going can help tremendously. And then just carving out time on a regular basis, which I recommend even for projects that don't have these problems yet. I recommend carving out time in some way, shape, or form. You may not need to do entire tidy Tuesdays or whatever you choose to do. Maybe just every time somebody finishes a feature, there's an expectation that if there are some flakes or mysteries in the code base, that's the next thing they tackle before they tackle something else. And then the other thing that I strongly recommend is reducing test execution time. Here's where I get to tell a story that, incidentally, this is for Aaron Tenderlove. Are you here? Okay, well, this is being recorded. So just so you know, this entire story is for him. Which the reason why will become apparent momentarily. So once upon a time, we were struggling with long build times, or long test times, and I was encouraging teams to think about shortening their test times. It kind of wasn't working. So I am not above bribery. At one point, I basically said, hey, tell you what, you lop an hour off of that test cycle time, and I'll bake you a pie. And the person I was talking to said, I like pie. And I said, well, it turns out I'm really good. I'm really good at making pie. These are real pies that I made. I'm pretty good at pie. So he lopped an hour off. The next day I brought him a pie. The other team members said, I like pie. And thus we formed a tradition. You lop a sufficiently large amount of time off of that very, very, very long cycle time, you get a pie. And it can be a collective pie. It doesn't have to be a heroic individual effort, but you get a pie. Because we want to reduce the time in our pipelines. You now see why this was dedicated. Anyway, let's bring it home. Healthy feedback loops. The things we have been talking about have to do with seeing to, so to see to the care and feeding of your feedback loops. You want to make sure you keep them tight, keep them short, watch those wait states, make them as short as you possibly can, given the context and those constraints, therefore, that you live within, but attend to the time in the feedback cycle. Think about the fact that you have these multiple levels. Too often I have had developers argue with me that unit testing is a waste because it's just going to get tested at the system level anyway, so why bother? I'm so glad I'm speaking to a community that doesn't buy into that thinking. Modulo JavaScript, which we can talk about separately. And then keep them clean, keep the pollution out of your feedback cycles. And I want to introduce you to one more feedback cycle. This is yet another one, should look very familiar. It's kind of like the others that we talked about, but this is the Kolb learning cycle. It turns out that experiment, experience, observe and reflect, and then abstract the lessons learned. That is also a feedback cycle. So in short, every feedback cycle is a learning cycle, and the more of those feedback cycles you get, the more you get to learn. Which is why I say there is no failure, there's only learning, but I'll also tell you that there are some weeks when I do a lot of learning. All right. I am down to 55 seconds on the clock, which means that I don't think we've got time for Q&A. I am here all day, though. Love to talk about this stuff. Would love to talk with y'all. Thank you so much for having me, and thank you for laughing at my jokes.